Today in Capechi's Corner, we're going to talk about probability. In looking at probability, we want to know the probability of an event happening. So our numerator, as we see, is the number of favorable outcomes. What are our options? And our denominator is our total outcomes, so how many things total possible. So in our example, it says, what's the probability of flipping a coin and getting a head? So there are two options, a head or a tail. So that's total outcomes, that's our denominator. There's only one head on the coin. So our probability of flipping a coin and getting a head is 1/2. Now what about a tail? Does that change our options? Well, no, we still have two options total. We have a head or a tail, and there's only one side that's a tail. So our probability of flipping a coin and getting a tail is also 1/2. When rolling a 6-sided die, what is the probability of rolling a 6 and then a 5? So we're doing two separate things. We have a 6 and a 5. So in my first roll, I'm trying to get a 6. There are 6 options because it's a 6-sided die. There's only one 6 on that die, so my probability of rolling a 6 is 1/6. Now I pick up the die again, and I'm going to roll it again. Now my die didn't change. There's still 6 options. And if I'm trying to roll a 5, there is only one 5 on that die. So I multiply across, and I have 1/36. That's the probability of rolling a 6 and then a 5. A drawer contains 4 red pens, 5 blue pens, and 2 black pens. You reach into the drawer without looking and pull out a pen for you and one for your work partner. What is the probability of picking? Now, number one, we're going to look to see what the probability is of picking a blue pen and then a black pen. Well, we have to figure out how many pens total there are. There's 4 red, 5 blue, and 2 black. So that gives us a total of 11 pens. That's going to be important. Now, there are 5 blue pens. So our possible outcomes is 11, and there are 5 that are favorable. So we have 5/11 times. Now for my partner, I'm going to pick a black pen. Now there are no longer 11 pens possible. There's only 10 because I have one in my hand. And so black pens, I have 2. So my probability, I'm going to multiply across, I have 10/110. And when I simplify that, I get 1/11. In our next scenario, we're looking to see what the probability of picking a red pen and then another red pen. So again, we have 4 red pens, so that's our favorable outcomes, over our total, again there are 11 pens in the drawer, times, now I already have a red pen in my hand, so now there's only 3 left in the drawer that are red and 10 total pens. So I multiply across and I get 12/110, which simplifies to 6/55. Now in scenario 3, what's the probability of picking a black pen and then a red pen? So there are 2 black pens, again 11 in the drawer, and red pens we have 4 available, but there's no longer 11 in the drawer, we're down to 10. So I have 8/110, which simplifies to 4/55. Let's look at the next scenario. It says you take a 3-question true or false quiz. You guess on all the questions. What is the probability that you will have a perfect score? Well, let's say what's important. We have 3 questions. It's true or false, so I have 2 responses. So I can only get true or false. That's my possible outcomes. Only one of them will be correct, and it doesn't even matter whether it's true or false. Only one will be correct. Now, this is the question number 1. We have question number 2 actually has the same probability, right? There's 2 total options and only one is correct. And the same thing for the question that's third. So when I multiply across, I have 1/8. That's the probability of getting a perfect score, regardless of whether the answers are true or false. A cafeteria has 5 turkey sandwiches, 4 cheese sandwiches, and 3 tuna sandwiches. There are 2 students in line, and each will take a sandwich. What is the probability of the following scenarios? The first scenario says the first student takes a turkey sandwich, and the second student takes a cheese sandwich. Well, again, we have to figure out how many outcomes we have. We have 5 turkey, 4 cheese, and 3 tuna, so that's a total of 12 sandwiches still in line available to the students. So the first student takes a turkey sandwich. So again, there's 5 turkey. There's a total of 12 sandwiches available. Now when the second student goes to get a sandwich, there's only 11 left. And he or she wants to choose a cheese sandwich, which is 4. So it gives us 20/132. which simplifies to 5 over 33. The second scenario says the first student takes a tuna sandwich and the second student takes a tuna sandwich. So again, there's 12 total sandwiches available. So first we have 3 sandwiches out of 12. And then there's only 2 tuna available because one's already taken. And again, only 11 total sandwiches, which gives us 6, I'm going to write it over here, 6 over 132, which simplifies to 1 over 22. In our next scenario, it says a candy store has 8 boxes of fudge left to sell for the night. 6 boxes are 1.5 pounds and 2 boxes are 1 pound. What is the probability that the next 3 boxes of candy sold are 1.5 pounds? So our total boxes of fudge is 8, so that's going to be my denominator. We're looking for 1.5 pounds. That's our favorable outcome, and there are 6 of them. Now, I could simplify that 6 over 8, but I'm going to use my calculator, so I'm just going to leave it. Now, I go to grab another box, and now there's 7 left. And again, 1.5 pounds, one has already been taken, so there's 5 left to choose from. And in our third box, again, there's 6 boxes total left, and only 4 that are 1.5 pounds. So when I multiply all of these together, it simplifies to 5 over 14. Our next scenario says Natalie has a bag of bows. The table below shows the color of the bows in the bag. So we have a list of colors and how many bows total for each color there are in the bag. Now when I total these up, I need to find out how many total bows there are, and there are 25. So our first question says if Natalie picks a bow at random, what % chance is there that the first 2 gifts she wraps will have a white bow? So I have 25 total, and I have 6 white bows. Now when I go to pick my next bow, again I only have 24 left, and I already picked a white bow, so that's going to be 5. So when I multiply across, I have 30 over 600. And again, I don't need to necessarily simplify that. When I turn that to a percent, I get 5%. Now the same thing in our next scenario says what % chance does Natalie have of picking a red bow, a blue bow, and then another red bow? So again, red there are 4 out of 25. And then there are 24 bows left. And a blue bow we have 7. Now we go to pick another bow. Now there's only 23 left in the bag. And now we have to go back to a red bow. There were a total of 4. I have already picked 1. So I have 3 left to choose from for red. I multiply across. And I get 84 as my numerator. And 13,800 as my denominator. So when I put this in percentage, my decimal is going to be 0.0060. So that actually becomes 0.6%. Remember, I go 2 decimal places, so I have a 0.6% of picking a red bow and then a blue bow and then another red bow.